Yes, am I audible?
Yes, sir.
Yes, sir.
Good morning to all of
Yes,
you.
sir.
Good morning, sir.
Let's
Good
Good
morning.
morning, sir.
start with the next lecture of Unit 5th. Yesterday we have started the new unit, that is the robotics, and yesterday already we have discussed the introductory part and the definition of the robotics historical points, also the uses and the application of the robotics. So today our two important points we will discuss in this topic. First is the fundamental problems in the robotics and path planning for the robot. Now, if you see the in case of the human being also, when the human being has to go from one particular location to the another location, or if the human being has to change his position, then he has to find out the certain path, certain way to go from one particular position to the another position. Okay. Now, similar is the thing for the robot also. Okay. And accordingly, the robot can be referred by the certain names. Okay. Now, when the robot is present at certain point, okay, when the robot is present at certain point, then at that particular point, okay, robot has to determine its position in the sense where he is actually present. Okay. And after determining its position, then only the robot can operate or robot can perform the certain activity. Okay. And so when the robot is doing such kind of things, okay, he is determining its position and try to operate from that particular point. Okay. Then in that case, that particular robot is being considered as a point robot. Okay. Why it is being considered as a point robot? Because of its single point operating feature in the specific environments. In the specific environment, in the sense, in the specific location or the area. And that is the reason here I have mentioned the abstraction of the autonomous robot in simple form is called as a point robot because of its single point operating feature in the specific environment. Now, what do you mean by the autonomous robot? Yes, autonomous robot in the sense that particular kind of robot where the user is not interfering with that robot. User is not interfering with that robot in the sense robot is operating by themselves. Okay, there is a no need for the human to interfere with that robot. Okay, so that particular robot is called as what, the autonomous robot. Okay, and that autonomous robot being also referred as, here you can see here I have mentioned the point robot. Why it is being referred as a point robot? Because it is operating from certain particular point. He has to determine its position and then only he can perform certain kind of activity. That is the reason that robot in the situation where it is operating from certain point, that kind of robot is being mentioned as a point robot. Okay, and when he is operating in certain environment, now that particular environment or the position, for example this position, now this particular position, as I have mentioned here, the specific environment, so that is being represented with the help of some Cartesian plane. Okay, what do you mean by the Cartesian plane? Cartesian plane in the sense this position is being represented with the help of some x and y axis. What? X and y axis. So that Cartesian plane is nothing but x and y axis. Okay. So in this way, the robot position is being represented with the help of the Cartesian plane, that is in the form of the x and y axis. And the same thing I have shown here in this formalism. It is possible to represent the robot as a point, as you can see here, x comma y belongs to the r. Now here r stands for the radius in which that robot is present. Okay, so in this way the robot's position can be represented in certain environment, okay, with the help of the Cartesian plane. And so this plane is nothing but, as I said, it is the domain or the area where that robot is actually operating. So that is, from this we can say the state of the robot or position of the robot is explained in detail by the this x and y axis point. And this particular representation is called as a pose in case of the robot. This is called as what? As a pose or the configuration of the robot. Okay. Now when this robot will move from this particular point to some other point, for example this point, tell me whether robot's configuration will change or not. Yes, if robot is present at this configuration and it moves from this point to the next other point, then tell me its configuration will remain same or it will get changed. Yes,
Change.
definitely the configuration of that robot or position of that robot, or you can see here, so that pose of the robot will get changed. Just like
Change.
the human being also move from one location to the another location, its location parameters also get changed. Understood? So the group of the poses or the configuration of the robot which are valid are also being referred as the free space. Free space. The group of the position which are valid are considered as a free space of the robot. There can be some spaces which may be considered as invalid, and some spaces may not be occupied by the robot. Now, what do you mean by the free space? The group of the poses which are valid are considered as a free space. Now, how can we describe the free space? Means what? Here, free space, I have represented it as a C underscore free. So the positions of the valid positions are which positions which are being referred here as a free spaces. Now, what do you mean by the free spaces? Yes, free spaces are considered as a valid positions in case of the robots. So what do you mean by the free space? Suppose,
Predefined.
no, can't hear you. Yes, repeat.
So free space म्हणजे predefined spaces.
No, let me tell you. For example, now in case of, if you apply the same, if you want to, in case of the human being also, suppose you are walking in certain area. Okay, when you are walking there, there you find when you are walking there you find uh, okay, there you find when you are walking on the certain, for example you are walking alongside the road, and you find that next to you there is some obstacle. What? There is some obstacle in the sense it can be anything. It can be any car or bus or anything that can be present on your way. So this particular area, is this area, we can call it as a free space, this area. Yes. Okay, understand the situation what I am saying. Suppose you are walking, okay, in certain area, and on your walking way there is some car present. Okay, car or anything, the certain obstacle is there. Okay, a big stone can be there on your way, and you have to reach at this position. Now this particular, this is the obstacle on your way. Now is it the free space for you?
No, sir.
No.
No. Understood. So free space is nothing but what? The space where there is a no obstacle is present. Understood. So in case of the robot also is the same thing. If the robot is moving from certain one particular position to the another position, and if there is a certain obstacle present in his way, then that particular area is not considered as a free space. Okay. If there is a nothing present on his way, then that every area is considered as a free space. And that is the reason here I mentioned the position which are valid positions are which only which are considered as a
Free
whatever the
space.
free space. Okay, if the free space is not there, then we cannot say that particular position as a valid position for the robot. So there can be a valid position, invalid. Okay, and there can be a position occupied by the robot, position not occupied by the robot, etc., etc. So here I have mentioned the free space configuration of the robot. Free space of the robot is simply consist of the area which is not occupied by the any kind of obstacle. That particular space is considered as a free space for the robot. Okay. So any configuration within this space is also considered, if the space is free, that configuration is also considered as a free configuration in case of the robot. Okay. So based on all these discussion, and one more thing you should keep in mind, the space which is occupied by the robot is represented like this with simple representation. The space which is occupied by the robot, what is this? R minus C free. R is what? R stands for here what? Space which is occupied by the robot is represented as like this. Means what?
Radius.
Radius minus C free. So whatever the, if you want to know the space, if you want to represent the space which is occupied by the robot, so it is being represented like this: R minus C free. C free is nothing but the free space. So from whatever the discussion that we have done up till now, from that the different question arises or the different problems raised regarding the particular robot. Now, as I said, when the robot is present at certain point, position, and doing some activity, to that robot, what we are calling point robot. Correct? Yes.
Yes, sir.
But when robot will start moving from one position to the another position, can we call it as also the mobile robot?
Yes, sir.
Okay, so that is the mobile robot. So if you consider the robot which is moving from one location to the another location, regarding that different question arises or the problem arises which has to be solved so that robot can able to move from one location or one position to the another position. Okay, now what are that question that can be arise from the discussion that we have done? In case of that first question is what? Can we relocate the robot from one configuration to the other while remaining within a C free? Means what? What is this question? Can we relocate the robot from one configuration to the other while remaining within a C free? Yes.
Yes, sir.
What is the meaning of this? I'm asking. Hmm? Yes. What is the meaning of first question?
change position of robot
तो क्या हम रोबोट को एक पॉइंट से
given space.
दूसरे दूसरे पॉइंट पे ले जा सकते हैं? ओके, एक पोजीशन से दूसरे पोजीशन पर ले जा सकते हैं, जो कि दूसरी पोजीशन भी क्या हो, फ्री हो.
Yes.
Is it possible? Okay, so this is the important question arises. If it is possible, then how? Okay. Second question also arises, if robot knows the whereabouts regarding the its sea free, then what is the way for robot to determine it? Tell me what do you mean by this? If the robot knows the whereabouts regarding its sea free, then what is the way for the robot to determine it? Hmm? If the robot knows the whereabouts regarding its sea free, then what is the way for the robot to determine it? अगर अगर रोबोट को पता है कि वो कौन से एरिया में है, कौन से लोकेशन पर है और कौन से फ्री स्पेस में वो प्रेजेंट है, अगर रोबोट को पता है तो कैसे पता होता है वो रोबोट को? हाउ द रोबोट डिटरमाइन दैट where actually he is present, in which free space he is, where about in the sense where actually the robot is present. So that is the reason here my question arises, what if the robot knows the whereabout in the sense where actually the robot is present. So if the robot knows the where actually he is present regarding its c free, regarding its free position in the free space where robot is present, then what is the way for robot to determine? Robot वो कैसे डिटरमाइन करता है कि वो कौन से फ्री स्पेस में अवेलेबल है, कौन से कॉन्फ़िगरेशन में वो अवेलेबल है, ये रोबोट कैसे पता करता है? दैट इज आल्सो द अनदर क्वेश्चन अराइजेस. Then third, what is the way for the robot to determine its pose and the see free if it does not know, if it is does not have the knowledge of both? So it's the same kind of question like the first. Second, robot, how the robot determine its position, its free space if he don't know about both the things. Okay, its position as well as its free space. So what is the difference between the position and the free space, or both the same thing? Yes. What is the difference between the pose and the see free? Is there any difference between the pose and the see free?
Yes.
What is?
So pose means तो आता ज्या ठिकाणी उभा आहे ती पोझिशन आणि सी फ्री म्हणजे तो जसा मूव्ह करणार आहे ती फ्री स्पेस विदाउट ऑब्स्ट्रॅकल.
Yes, correct. So the actual position and whether it is a whether when you try to move, whether that position is the free or is there any kind of obstacle, etc. So how the robot determine all these things, that is also the, so these are the different question arise if you think about the mobile robot. Understood? And what we are to do, we are going to find the answer to this question in the further section of this unit. How the robot determine its position, how the robot move from one point to the another point, how he can handle if the obstacle is present in his way, etc, etc. So these are the things that we are trying to find out. The question being asked on the note on the fundamental problems in the robotics. So this kind of things you can explain in that case regarding the fundamental problems or the question that can be raised regarding the mobile robot when you try to move from the one point to the another point or from one configuration to the another configuration. So the next important topic, that is nothing but the path planning for the robot, on which the 8 mark question being asked number of times. Path planning for the robot, and in this topic we are going to discuss one algorithm also using which the path planning for the robot can be done. Okay, so here we have given some initial configuration, and from that initial configuration the robot has to move to the some destination point, okay, or to the target configuration. Okay, so here you can see starting configuration for the robot is given. You can see the starting configuration for the robot is given as, which is being represented here as a s equal to a comma b. This is the point. Can you able to see this?
Yes, sir.
So starting configuration for the robot is given as this point, which is being represented here as a comma b, and we want to shift, or robot want to go to the another configuration. So here this is the starting, and robot want to go to the another configuration. This is t configuration, means to the another point which is being represented as a t, and its configuration is represented as the c comma d. Okay, so in order to plan the path from s point or s configuration to the t configuration, we have to decide the path, okay, which join this s and t, and accordingly the robot has to move from the s to t. So you can see the starting point as the s and the end as the t. So if robot want to move from this starting point s to the t, okay, so what is the necessary thing is there? If robot want to move from this point s to the t, so first necessary thing is what? This particular point s as well as the point t, they must be in the free space. This is the first necessity. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
And there must be a existence of path. त्यांच्यामध्ये काय path असला पाहिजे. Path should be the exist between these 2 points. Then it is possible for the robot to move from this S point to the T point. So what we have to do, what we have to determine, we have to determine whether the existence of path is there from the point S to the T, and if it is existing, then how the robot will move from point S to the point T. So how it can be done? Only way to do it for the robot is nothing but doing the searching. Yes or no? So only
Yes,
through
sir.
the searching in this particular continuous space for the existence for the continuous path. So robot can move from this point S to the T only through the searching. Searching what? Searching whatever the space is there available, and so that through the searching it can reach to the point T. So in order to do this kind of searching, how the searching will get done, etc., etc., we have the particular algorithms there. Okay, there are the various algorithms are there for path planning in case of the robot, but just one out of that we are going to discuss here. Okay, which will give us the solution for path planning regarding the robot, and that algorithm is here. You can see being refer it as here as a bug to algorithm. What? Bug to algorithm. Okay, now let's start how we can reach from this particular point S to the T. Okay, and this all the steps are shown in this figure. You can see. Okay, now consider, as we have considered the current position of the robot, current position of the robot as this S, which is being represented as a configuration A comma B. Here also I have mentioned the current position of the robot is at S, and we want to move it to the T. Means robot want to move to the point T or area T, and you can see if there is a existence of direct path, that is a straight line. Okay, if there is a, now what is the easiest way for the robot to follow the straight line path? Correct? like this. You can see this
Yes,
is a
sir.
straight line path. But can you tell me, is it possible that every time robot will get the straight line path?
No, sir.
No. So this is the what we can say the ideal solution for the robot having the straight line path. If the straight line path is available, now what do you mean by this? How, when the straight line path can be available for the robot? When it is possible? Yes. When the
When
straight
there
line
is
path,
free space.
when there is a free space, in the sense when there is a no obstacle available between that particular starting position and the starting location and the target location. Understood? But it is not possible that every time robot will find that kind of ideal situation where there is a no obstacle between their between his way or between his path. Okay. And so if the path of the robot is obstructed in the sense, if in the path of the robot there is an obstacle, then it is necessary for the robot to go through by circumnavigating that particular obstacle or the object until he encounter the particular straight line. Okay. What do you mean by the circumnavigation? Yes, this word. Yes, circumnavigation means what? Hmm. This is the combination of two words, circumference plus navigation. Yes. Circumnavigation राउंड करून
राउंडेड
की त्या जर जर रोबोटच्या पाथ मध्ये कुठेतरी ऑब्स्टॅकल आला, हिअर ऑब्स्टॅकल इन द ऑब्जेक्ट हिअर आय मेन्शन, तर त्या पूर्ण त्या ऑब्स्टॅकलला कव्हर करून robot has to move until he encounter the straight line, until he find the straight line. Okay, until he find the straight line म्हणजे काय? So robot is also having their sensors etc along with that. So using that, as I said, you can see the robot already know. What robot already know? Which things robot knows?
फ्री स्पेस.
First, that he knows his source location. Correct.
येस.
And second thing he knows is what? की त्याला जायचंय कुठं? He know the target configuration. So using these 2 points, using these two configuration, he can make the straight line. Yes or no? की हा त्याचा ideal path आहे. Am I right or not?
येस सर.
He can make this straight line using this sensor and all these things. Okay. So that is the reason I have mentioned here. If the path is obstructed, then it is necessary for robot to go through by circumnavigating that object or obstacle until the robot encounter the straight line. Okay. So let's try to apply it in the example. So consider there is an obstacle P. Consider there is obstacle P. Now from here our robot will start moving, correct? Okay. So the dash line path, you can see the two paths in this diagram. The dash line, this is the dash line path. Okay, straight line, and another is the solid line. So solid line path is being created by the robot itself. Okay, we'll see that. So consider there is an obstacle. Now robot start moving here. Can you able to see this properly? Yes. Okay. So robot
Yes, sir.
starting from here, then it goes to this point. आता हे जे तुम्ही बघताय, हे these things you are observing, this is the obstacle. आता ऑब्स्टॅकल म्हणजे तुम्ही काही म्हणा, दगड म्हणा, काही वॉट एव्हर थिंग यू कॅन इमॅजिन. Robot start moving from this, and when he go to this point, he encounter the obstacle. We call it as a P. Okay. Yes. He start moving from this, and when he start moving, at some point he find there is an obstacle. Okay. Now what the robot should do when he encounter the obstacle in his way? So then robot should go around the obstacle unless it is able to continue to move to the goal position T along the line ST. Line ST Okay, this is the line ST, dash line is the ST. So robot has to circumnavigate this object like this. He move around this object like this. He will go moving, correct? Okay, like the same thing here shown in the B part. Robot start moving, then third here and in this way, correct? Able to see?
Yes, sir.
And when he start moving now, until what situation he has to move? Until what situation he has to move? Robot has to move
Until it encountered the straight line.
until it find the until the robot
Straight
will
line.
find the straight line. So when the object will get when it is when it is go on navigating this object or obstacle, then definitely at certain point definitely he is going to find the particular straight line. So like this, okay, he go on moving, and for example at this point he find that straight line. So the same thing, the robot travel all the way to around the obstacle until it get to a point on the obstacle on the line ST, from which it will be possible to leave the obstacle in the way for target T, which is closer to T as compared with the point P at which it will go on traveling by avoiding the obstacle. Okay. So robot, after he encounter the straight line, robot will not. So will the robot circumnavigate the whole obstacle like this? Yes. Is there any need to do this?
No.
No. So whenever, because already he has made the one straight line, he has already made the straight line, and when he find the straight line, so again his journey will start from this point like this. Okay, like this you can see in the next part I have shown. So his journey will start again, he find the obstacle here, correct?
Yes, sir.
So again he go on circumnavigating the object. Okay, and when you find again the straight line, then you can see here it reaches to the
Goal
end
position.
configuration. But what if he never find the straight line? Yes, sometime it can be happen, yes or no?
Yes.
So in that case, it indicates the path is not exist. Okay, and in that case robot will have to return back to the previous point P from where he has find the obstacle. So in this way you can see the same thing we have shown here like this, and robot goes on to the target position. Okay, so you can see the same the discussion that we have done here, same you can put it in the algorithmic way. Okay, and that you can see here, visualize the direct path ST. Okay, from the starting point S to the end T. Okay, and you can see while the goal T, while the goal, so these things will continue until the while goal T is not achieved. Okay, so begin while the path ST to the goal is not obstructed. Do begin move towards the path along the path ST. First situation काय की तुमच्या पाथ मध्ये कुठल्याही प्रकारचं ऑब्स्ट्रॅकल नसेल तर काय होईल, मग रोबोट विल गो डायरेक्टली फ्रॉम दिस पॉइंट टू दिस पॉइंट. Yes or no?
Yes, sir.
The same thing mentioned, while the path ST to the goal is not obstructed, do begin the move towards the robot will move towards the goal along the path ST. But if the path is obstructed, second case, if the path is obstructed, then begin mark the current location as a P, circumnavigate the object until the robot circumnavigate the object until what? Until these two situation. Circumnavigate the object until until the robot hit the line ST at a point closer to T than P and can move towards the T, in which case the robot follow the ST. Okay, circumnavigate the object until he reaches to the straight line ST. Second case, return to the P, where in which case the T is unreachable. So if he don't find the straight line, he has to, what it means, this particular target is unreachable. So in that case, he have to again come back to its initial point P. Okay, and end. So simple algorithm is there. Okay, understood?
Yes, sir.
So this is the bug to algorithm in case of the path planning for the robot. Like that, there are also other algorithms are there for, but it is sufficient for our study to have just one algorithm regarding the path planning for the robot. So in this way, the robot does the path planning and it can reach to the target or the goal position. Okay. So that's it from the today's session. Next part we will continue in the next lecture. Okay. Okay, so the Pandav sir has put one notice. The three students, okay, Mangre, Rohini More, and Naikode, urgently they should send your passport size photo to Pandav sir. I hope all of you got that message. Yes.
Yes, sir.
Yes, sir.
हाँ, urgently
Yes,
send
sir.
करा दे. ठीक है. Okay.
Yes.
Thank you all of you.
Thank you, sir.